Hello, my name is Christopher Tate, and I want to show you how to set up a virtual machine for DNS and identity management to open our Openshift web console and routes to the network. In my previous video, I created a base virtual machine image, and I have other videos showing how to properly set up a libvirt hypervisor and Openshift with valid SSL certificates. So check those out if you've not already. Before we create our new virtual machine, we will install Synching on our hypervisor to sync the certbot SSL certificates we created earlier for our domain name so that the applications on all computers can access these. Synching can sync files nearly instantly over the network or over the internet securely. It's my favorite way to share files, and it is open source. We will use it to share the directory of our SSL certificates for our domain with all physical and virtual machines on the network. I explained how to install Synching in my previous video. I have also explained how to do it again below on the computer where your certbot certificates are generated. I've already installed it here. So first we will set up some environment variables to help us create a directory for all SSL certificate related files for our domain name. So I open up a terminal and you can find these commands that I'm about to run below. But first I'm going to make sure I have sudo access okay, and I create a environment variable with my domain name, heytate.com. For you, it's going to be different. Now we set up a directory for our SSL certificates, like this. Now copy the certbot certificate and private key to the new directory, like this. Now, the paths to these files are going to be slightly different for you. But we copy from the /etc/let's encrypt /archive/ domain name. It might be your domain name -2 or some other version, whatever it told you with the latest creation, into our new directory here and name it server.cert. And for the private key, it's similar. We'll name it server.key. So you get those into the new directory, and now make your user the owner of the directory and all of its contents, like this. Next, obtain all the root and CA certificates from Let's Encrypt. We can do that with these 3 wget commands. We will now merge the Let's Encrypt root certificate, the second Let's Encrypt CA certificate, and our site certificate, which also contains the first Let's Encrypt CA certificate, into one file. We do that like this. with the cat command. Now we have a new file called merged.crt. Now to generate a .p12 file from the merged certificates and private key file that the ipa-server will use. The name of the .p12 file is your domain name. So notice that we specify in the merged.crt, we specify the in key as the server.key private key file, and we output to a server.p12 file. The name is the network domain name. Now it's going to ask for a password, and you're going to want to keep track of this password for later. So I will give this a password. And enter it again. Now we will share our SSL certificate files with other devices on Synching. You'll notice here in /srv/heytate.com, we now have these files. So we want to sync these. So we can open up Synching here. Like that. Sometimes this command takes a while. There it goes. So we open up to Synching, and I already have some directories here, but I'm going to add a new folder. Click the Add Folder button, and so I'm going to give this a label of heytate.com, my domain name. I'm going to make that the folder ID as well. And then the path to it is /srv/heytate.com. And we will share the folder on Synching like this. Okay, we don't need to share it with anything yet. So we click Save. And now it's ready to sync. But it says it's unshared. That's because nothing is synced with it yet. Okay, so with our existing base apps disk image, we can easily set up another virtual machine with most of the applications we need already. You can actually use the base apps disk you created in the previous video as a 2-layer disk for this next virtual machine, or you can copy the file and have separate copies. You can choose which way you want to do it. Just for a bit of isolation, I have copied the base apps disk and created a new one for my virtual machine, like this. This is a new virtual machine I will call IPA1. We are about to install an ipa-server, and it is possible to have a highly available ipa-server if you want to. So I will assume that there may be more than one ipa-server on my network. So I choose a name of IPA1 for this one. We will copy our base apps disk image to a new one for the IPA virtual machine, like this. Just by using the cp command. Mine is in a slightly different place. IPA1.qcow2. And you'll notice that these are the exact same size. So it should be good to go. With our disk image copied, we will open virt manager like this, sudo virt-manager. Let me bring that over. Now click the Create a New Virtual Machine button. Choose how you would like to install the operating system, which is Import Existing Disk Image, and click Forward. Now provide the existing storage path. We browse. We choose the right file system directory. For me, it's this one. And I will choose the ipa1.qcow2 file and click Choose Volume. I'll specify the OS type as Linux, and the version as CentOS 7. Forward. For RAM, I will give it 2048 MB and 2 CPUs. This is really up to you, what you want to choose. Click Forward. And now I give it a name of IPA1. And I will customize the configuration before install and check my network selection. So it's bridge, which is perfect. That's what I wanted. I click Finish, and now I can review all the changes. I want to make sure that the QEMU guest agent is installed. So I look for a channel QEMU with the device type as Unix and the target type virt.io, target name org QEMU guest agent.0. That looks good. So with the guest agent installed, I click Begin Installation. Here is our new virtual machine. So we'll let it boot. Go ahead and log in. Now you'll notice that the display is cut off. So you can use the guest additions functionality you added to the virtual machine by going to View, Scale Display, Auto Resize VM with Window. And then it resizes, and I can stretch it out. Oops. Like that. And it resizes again. Pretty cool. Okay, at this point, you will want to activate and start the Synching service and sync the certificates from the hypervisor to the IPA1 server. So we open a terminal here. sudo systemctl enable Synching at $user and notice that it enabled Synching at ctate.service. Perfect. So Synching will run as our user. Now I can restart it and check its status to make sure it's working. Good, it's active, running. So each computer in the Synching cluster will need to trust each other. You can do that on each computer by supplying the IP address of the other computer to add to a trusted zone. For example, the IP address of my hypervisor is 192.168.1.13. So I copied that to the clipboard, and then I will put this command in here. And your virtual machine can actually copy and paste from your hypervisor to your virtual machine and back. So that's pretty nice. So I add the hypervisor as a trusted computer to my virtual machine permanently. And we did that earlier when we set up the base image. Now, I want to get the IP address of my virtual machine and do the same thing on the hypervisor. So, so we put in this command, put in our IP address, good. And to reload it, firewall, sudo firewall-cmd --reload. Now they should be able to sync with each other. The firewall will not block it anymore. Okay, now that we have our certificate directory, we can make it available to Synching. So you can access the Synching web UI here. Let's see. So let's do this on the virtual machine. So we open up Synching. There it goes. You can choose to allow anonymous usage reporting or not. These devices need to accept each other, so obtain the ID of the Synching server on the hypervisor. So I go to this Synching, actions, show ID, copy that to the clipboard, and go back to my virtual machine and click Add Remote device. Paste the ID here. It finds other ones on the network automatically, and it recognizes this one here. So we put in the device ID and the device name, and I will call that Tower 2. It's the name of my hypervisor. Save that. Now, the IPA1 virtual machine will ask the hypervisor, can I sync with you? So then go to the sync thing on the hypervisor and wait for the request to appear. It may take about a minute. There it is. I click Add Device. Give it a name that you want, like IPA1, and save. We can also go to sharing and share the heytate.com directory with that device. And click Save. Now the hypervisor will share the certificate directory with the virtual machine. Go to the IPA1 virtual machine, specify the name of your domain as an environment variable. So let's go to the virtual machine. It's ready to add that, but before you do, let's add this environment variable here with our network domain name. For me, it's heytate.com. For you, it's going to be a little different. Then create a directory for the certificates and make your user the owner. Password. Let me fix that real quick. Okay, that should be that. Okay, so now we have a empty directory, serve heytate.com, that's owned by me. So in Synching, you can now accept the directory to be synced and specify the path to the directory you just created. If Synching takes too long to sync the directories, you can specify the same folder ID directly on both sides and they will sync. So let me show you. Here, it made the request, so I click Add. And now I just need to specify the right folder path to srv/heytate.com, and they will stay in sync. So now, if I see what's in this file, there they are. They're immediately there. Yeah. So now, we have our certificates. To get started setting up the IPA server on the new virtual machine, we will set up some more important environment variables. The IP address of the hypervisor. For me, it's 192.168.1.13. It's going to be different for you. The IPA certificate password will be the password you created earlier for your .p12 certificate file. For me, it's my password. Make sure that got set correctly. Okay, the realm name, which is the domain name, but all uppercase instead. See how it's heytate.com, but all uppercase? Now, the host name for this ipa-server virtual machine. For me, it's going to be ipa1.heytate.com. Now, the IP address of the IPA server. We can do that like this. So for me, it's 192.168.1.26. You can see that here. There's my Ethernet IP address. Last, we need the Ethernet connection name to update the DNS server for it after the IPA server is installed. So we do that like this. For me, it's wired space connection space 1. Now we will add this IP address and host name to /etc/hosts. Like this. So take a look at etc hosts, and you'll see the defaults here for localhost, but you'll also see this record for our IP address and host name, which will be important for the IPA server install. And we can update the host name of our computer, of our virtual machine, like this. With the nmcli general host name command. And then we type hostname, and it's set. Okay, now we install the prerequisites for the IPA server, which are ipa-server, ipa-server-DNS, bind, and bind-utils. We want the IPA server and the DNS functionality for IPA server. Now, this may take a little while. Now this is the command to install the IPA server. Sudo space ipa-server-install space --allow-zone-overlap. This will allow it to proceed if it finds DNS records online for your domain as well, which is okay. -r $IPA realm name. This is the realm name, which is the domain name, uppercase. -n space $network_domain_name, which is the domain name, space --mk home dir. This will create home directories for users as they log into their machines. Yes, the IPA server is a central management server for users, passwords, RSA keys, groups, to all your computers that join, and much more. space -- host name is the host name of your ipa-server host name. -- host name equals $IPA _ host _ name space -- IP - address equals $IP _ IP. Sorry, $IPA _ IP _ address, which is the IPA server IP address. Space -- setup - DNS. We want our IPA server to be a DNS server so that we can use it to resolve internal host names on all devices that use the DNS server. Space -- dir srv - cert - file equals /srv / $network _ domain _ name /server.p12. So this is the .p12 certificate file that the directory server will use. Similar, we will include the HTTP cert file and the CA cert file, which is the first CA certificate. And now we will also include the dirserv pin and the HTTP pin and I put those in quotes in case there's special characters or spaces in those. Those are the passphrase that's the passphrase to open the .p12 file. And we add no PK in it because apparently certbot certificates are not valid to use as a Kerberos KDC certificate, but that is okay. Mainly we wanted the HTTP management console to have a valid certificate. So we will run that command. Okay, so here you can set up a directory manager password. And here's where it's useful to use Synching because we can keep track of these in Synching. So I'm going to do that. If I open up, no, what did I say? I said Synching. I mean Password Gorilla. So I can create a new database. Choose a master password. And I can create a directory in there like IPA1. And add a login like my server.p12 file, which has a password of my password. Let's see. Hey, we'll do username of heytate.com. All right. So then, this is saying it needs a directory manager password. So let's add a login for directory manager. So then I can make a password and copy it to the clipboard by clicking on Directory Manager and pressing Control P, and then paste it in there twice. Now we need a IPA admin password. So this is a user called admin in the IPA server web console, and so let's give it a username admin. Give it a password. Do you want to configure DNS forwarders? We'll say no. Do you want to search for missing reverse zones? We'll say no. Continue to configure the system with these values. We'll say yes. And there goes installing the IPA server. And I want to save this database here. And I can save it in my shared directory if I want to. srv, heytate.com, heytate.com.psave3. There we go. And that'll sync to my other computers, like my hypervisor, ls-l /rv/heytate.com, heytate.com.psave3. There we go. Okay, let's see how the IPA server's install is doing. It's upgrading itself. Okay, now your IPA server should be running. Now we will want to make a persistent update to the DNS server on the IPA server to point to itself with this long command here. We will modify our Ethernet connection to add the DNS of our IPA IP address and search for the host name and ignore the auto DNS. Okay. Now we will refresh our Ethernet connection like this. There's a quick refresh, and we can make sure we still have internet access. We do. And our sync thing rebooted real quick. It lost its connection, but it found itself again. So it all looks good. You will also want to allow these services, these IPA services, on the firewall of the IPA server. So we can open up all this IPA services like this. It includes NTP, HTTP, HTTPS, LDAP, LDAP-S, Kerberos, kpassword, and DNS. We'll do that permanently and reload our firewall. You can also add the username and password you want to use on all the computers you connect to the IPA server, like I will do for my user Tate. First, we will try out our IPA server for the first time by logging in as admin. We do a knet admin, and it asks for our password. Oops, let's see. I have my password here, and that worked. You'll notice I'm the second half of this video is several days later, and I already forgot my password, but my password safe remembered it, so yay for Password Gorilla. Alright, so now I'm logged into the IPA server as admin. I have admin permissions. So with admin permissions, I can add a new user, like IPA. IPA is the command to interface with the IPA server. Space user-add Tate will be me. My first name is Christopher, and my last is Tate. Okay, my user is added, and I can give myself a password. Excellent. So there's all kinds of things you can do with this command line API here. For example, IPA group-add. I'll make a group called Openshift. And then I will IPA group-add-member Openshift --users equals Tate. And now my Tate user has a group of Openshift. Cool, right? Okay, so now we're going to try this out on a client computer on my system running Openshift. Start by listing your network devices like this, NMCLI device. So I am going to use my BR2 device, which is my bridge device. That's the one with my IP address. For example, I type in ipaddr, and I see that my BR2 network has the 192.168.1.13 on the network. So that's the good one. All right, so first we are going to put in a network Ethernet connection of BR2 Next, we will put in a network IP address, which is above here, 192.168.1.13. And my network host name, I'm going to call it tower2.heytate.com. My network domain name is heytate.com. My IPA host name is ipa1.heytate.com. And my IPA IP address, we can grab that straight from our virtual machine here. ipaddr 192.168.1.26. There. Now we can generate this environment variable like that, the realm IPA realm name. And now we will update etc hosts to add the network IP address and network host name of 192.168.1.13 and the host name of tower2.heytate.com. Now we will set up the network to use the ipa-server as a DNS server. So we update its host name, and with the hostname command, we will see it's now tower2.heytate.com. Now with this big command here, we will modify our connection to BR2, update the DNS to be the IPA address followed by 192.168.1.1, and then make this DNS search be the IPA hostname and ignore auto DNS. Great. Now we will update our networking with the NMCLI connection up to BR2. And it's activated, and we'll wait for the network to come back online here in just a moment. There it is. Looks happy, so we'll do a quick test. Ping google.com. This may take an extra second or two. There we go. We're back online. Okay, so now to install the IPA client prerequisites, now that we're back on the network with a DNS server. We sudo yum install the IPA-client package. Okay, that was easy. Now to set up this computer as an IPA client, we do sudo space ipa-client-install space --force-ntpd to use the same NTPD server that the free IPA server uses. --enable-DNS updates so that it retrieves DNS from our free IPA server. Space --mk homedir to create home directories when a user logs in. --server equals $IPA host name -- realm equals $IPA realm name space -- domain equals $network domain name space -- NIS domain also equals $network _ domain _ name space -- home no -- host name equals $network _ host _ name and enter my password. So we will say yes so that it uses with a single server, failover will not work, like free IPA failover. So free IPA will warn you about this, and you should enter yes to proceed. So we will configure it like that. It's got our host name, it's got our realm name, DNS, domain, our IPA server, and our base Kerberos information. I also wanted to show you, we can check that our DNS is working if we can ping our IPA1 server. For example, if I cat etc hosts, notice there's no entry for IPA1, but if I ping ipa1.heytate.com, it finds it. That's because our resolve/etc/resolve.conf, our network was updated to use this IP address, which is our IPA server, to be our DNS server. So our DNS is working. Cool, right? Okay. Now we will say yes here to continue. Okay, now it's asking for the admin user. So I type in admin and its password. There we go. It's working. Yes, IPA client was successful. So cool. Okay, now for example, if we go to the IPA server and ping tower 2, first let me show you the etc hosts /etc hosts as localhost and IPA1. So we do ping tower2.heytate.com, and we get its IP address on the network, 192.168.1.13. So the DNS is working on two sides. Yeah! Cool. So next, we now your system should now be set up with the IPA server for DNS and other nice things. Now we can add any DNS record we want to resolve our applications to Openshift, for example. So we can do that like this. We can do that either on the IPA server or on a client machine. So IPA space DNS record dash add space dollar network underscore domain underscore name. And then for here, I'm going to specify my wildcard route for my Openshift application, which is star.apps.dollar network underscore domain underscore name space dash dash a dash rec. And then this is going to be dollar network underscore IP. Actually, let me find the IP address here. IP adder of my Tower 2 computer, which is this 192.168.1.13. So I can put that in here. So what this is going to do is we set up our domain name. For me, it's heytate.com in the IPA server. And so this is saying create a DNS record, add a DNS record to the heytate.com domain. And it's going to have an A record of star.apps.heytate.com. And it's going to point to 192.168.1.13, which is our server, Tower 2 server, where my Openshift is running. So I do that. Oh, let's see. I need to log in here. Kinit admin. Now let's try it again. Oh, okay. Let's try this. There we go. There we go. Star.apps. So now we can open up Openshift. Let's add one more. In this terminal. This one's also going to be Openshift. Okay. Let's try this again. Let's make sure. Let's make sure this is running. Okay, I probably need to clean up my routes here. Sudo vim etc host. So I want to delete all of these so that the free IPA server, the IPA server can do its job. Okay. Now, openshift.heytate.com resolves to my IP address. So Let's try it. Oh yeah. And I forgot the port. 8443. Yes. Okay. So, yes. Look, it's got our SSL certificate. Let's see this. Which is a Let's Encrypt certificate. Cool. So we can log in here. This one, Jenkins. Let's see if this route works. Yes! Oh, man. Okay, so this is so cool. Okay, so HTTPS, it's got our Let's Encrypt certificate, and it resolves to jenkins-ctate.jenkins.apps.heytate.com. So let's try this out on the virtual machine as well. So I open up Firefox. And there's Jenkins on the whole network, my home network here, my little home network. We have Openshift web console and routes, Openshift routes to all my applications working with valid SSL certificates. So this is time for a little dance of joy. Okay, that feels good. So that's it. I hope you enjoyed this video. I hope you go and do it yourself. Thanks for watching.